I guess I'll start our video by having and recapping this. So we solved all four of these with the quadratic formula or by factoring. But in the quadratic formula, we noticed at this moment here, we had a number that we were adding and subtracting. That meant that we were going to get two solutions. We could simplify it. This one worked out to be nice numbers because the square root of 196 was a perfect square of 14. In this one, probably knew, well, basically here, also there, you were going to get two solutions again because you were adding and subtracting a number. So when you add the number, you get one solution, subtract the number, a second solution. But in this third one, when you add or subtract 0, you only get one solution. Because you will just have 8 plus 0, 8 minus 0, that's the same thing. And you would get 4 twice. I mean, when you factor it, you see that you get 4 twice. I guess technically, if you solved the equation where you added 0, and then solved it again where you subtracted 0, you would get 4 twice that way as well. But then there's only one solution. And whenever we get a square root of a negative, that's impossible. That's going to be no solutions. So the topic of this section is called Interpreting the Discriminant. And right above the discriminant part, I want you to write b squared minus 4ac. Because in our quadratic formula, which I'll write here, we call this part inside of our square root, we call that part the discriminant. And that's the part that's going to tell us whether we have two solutions, one solution, or no solutions. So on the next page, they say the solutions of 4 quadratic equations are shown below. So they've got work for us, and this is equation number 1. And I'd like you to, off the side, you can write equation number 1. There's going to be 2 roots, and in brackets, I'm going to get you to write the word rational, because if you get a perfect square, then you get nice numbers for your answer. Rational numbers are numbers that can be written as a fraction. Irrational numbers are like square roots and pi that go on forever without a path. Okay? So this first one beside it, you can write 2 roots, rational, and the discriminant part is positive, and the positive idea tells us that there's going to be 2 roots, and the fact that it's a perfect square, that's what's going to tell us that those 2 roots are going to be rational. Equation number 2, so off to the side, we're going to write equation number 2, again, has 2 roots. This time, they're irrational. The b squared minus 4ac is positive again. But it's not a perfect square. So because it's not a perfect square, we still get 2 answers. But this time our answers are irrational answers. And of course, as soon as you have an irrational answer, we couldn't solve it by factoring. Group 3, so equation number 3 here, discriminant is 0. Inside the square root was 0. And if you're adding and subtracting 0, you're going to get the same answer both times. So you only get one root. And finally, our last example, number 4 here. And the last one's on the next page. We get no roots because the b squared minus 4ac is negative. And those are our 4 situations, and they've highlighted them in the box at the bottom, or sort of in the middle of the next page. Okay? B squared minus 4ac greater than 0, that means your b squared minus 4a is positive. B squared minus 4ac less than 0, that's where it's negative. So if it's positive, you know there's going to be 2 roots. If it's negative, there's going to be no roots. So sometimes they ask you to not even solve the question and just say, how many roots do you think this is going to have? And if it's just asking how many roots you think it's going to have, you can sort of use a shortcut and just look at the discriminant part, the b squared minus 4ac, to determine that. Of course, you could still just solve it and tell that way too. Not necessarily bad to get the solution and be like, I got the solution has 2 answers, how many roots does it have? 2. But often you'll get questions like this one, where it says, oh, without solving, if you solve this, we have to deduct marks because you went too far. No, I don't think they'd actually deduct marks. But they're saying, how could you tell how many roots it has? And so whenever it's asking about how many roots, figure out what b squared minus 4ac is equal to. Okay? So the b, well, again, this is my a, this is my b, this is my c. It's written in the right form where one side is equal to 0. So my b would be negative 6 squared minus 4. My a is 9. My c is 1. If I solve this, it's going to be 36 minus 36, which is 0. And I can write, since the discriminant b squared minus 4ac equals 0, there are I guess I should use is. There is, and I should take an s off the root. There is 1 root. And you will see sometimes, I don't know if I like this, but I see sometimes in textbooks they write this. Two equal roots. It's basically 1 root that's the same thing twice. Kind of, right? I don't know. Maybe you should do that on your next science test. You get your answer, and you just write it down again and again and again, 15 times on. Right? I got the same answer 15 times. Maybe that's extra confidence. Would the teacher take off a mark off for each one if it was wrong? It's a little bit dangerous. I don't know. So for the most part, we'll try to say 1 root as much as possible, but sometimes you might see, depending on where I've gotten questions from, you might see that language of 2 equal roots come up. Okay? And this is how you would solve it. Like, we didn't actually solve the equation. Okay? If we wanted to solve this, it probably factors. Well, it does factor because anytime it's 0 inside will work out nice. There it is, 3x minus 1, 3x minus 1. You get 1/3 as the answer. You happen to get that answer twice. But that would be the solution. So if we solved it, we'd be able to say there's one root. If we didn't want to solve it, all we have to look at is the discriminant and interpret what that means. And since the discriminant was 0, we would know that there's only one root. Okay, so try 4, 5, circle these ones, 7, and 12.